I was frantically trying to like run some experiments while Adam was talking. I was not doing email, despite his claim. Okay, language enhancements. Like, I have very little to say on the topic, but it's been discussed in many cases. It seems to fall into sort of a couple different things, and we can brainstorm ideas. Sort of, hopefully people can read that. Iteration, I think oftentimes you need to walk linked lists and things of that sort, obviously without the use of backward branches. Notion of sub.
A little bigger. So you would read the white on black.
Oh, I can also switch the color.
Yeah, it was much better.
That's good. All right, it's a very long list, so subroutines, you often have common stuff you want to execute that you inevitably have to write these awful macros for and use them over and over and use the CP processor. NV lists are a fun construct, which is some combination of iteration and subroutines. How do you pick apart NV lists in a way that is useful? If else, within the construct of a probe, you've got the ternary operator, but the things it can do are pretty limited, and you have to basically construct your nested if-else control flow through predicates, which can get complicated. So, other things that bug people that can be added to this list, or do you just want to speculate on what some theoretical solution might be?
What do you? I mean, I'm wondering if NV list isn't the one that you run into personally most frequently.
And that's one of Matt runs into personally, because ZFS is all NV list.
Right. So I mean, one of these are kind of really burning people.
So the NV list, there's kind of a couple of different things. So one is being able to just basically have print for NV lists, which is we can solve that pretty easily just with a giant hack, special purpose hack of have the kernel, introduce some new instruction and have the kernel be oh, that means I should go take this NV list and serialize it and then send that up to userland, right? But we'd also we don't want to do that as a special purpose code. We'd like to make that general. And we'd also like to do things trace this member of this NV list. So take this NV list. I know that there should be an entry named whatever, and then get that out and trace it, or put it into an aggregation, or just use it in general.
Anything else? I mean, that one's hurting us. I definitely think.
Some people might not be able to do that. I also think that there's things besides NV lists that are interesting like that, like the ABL structures.
Right, and now I shut my my laptop. So I thought I would show what I'm sure some people here's my example of what I'm sure a lot of people have done when they need to walk some kind of structure is you basically keep track of where you are, and then you define it as a macro, and then just print it as many times as you're willing to do. So
this rate increase the dot max size.
Yeah, exactly. So this stupid example is.
It seems like we need to walk, right?
Yeah, I mean there's a couple. Let me just. This is what happens when I close my laptop and the network is slow. Wake up. VPN. Anyway, I will attempt to run that just for people who haven't had the pleasure of writing constructs like these before. There we go. This guy is asleep, still waiting. So anyway, I think there's a couple. So if I run this, basically when cat comes over here, it prints however many times I chose to, cut and paste that macro.
Basically an unrolled loop.
Exactly. So I think there's a couple ways one could address this. Obviously, introducing backwards branches is a non-starter, so we're not actually going to generate diff that literally loops, because then you have to solve the halting problem.
If you have a backward branch that could only be taken a file.
Well, I'll show you something that I hacked up that was based on some conversations that Matt relayed to me in like 30 seconds.
Gave you a dream.
No, it's sort of like this concept of subroutine slash iteration, where if you had the ability to call a function that didn't return something, right? You're not going to block and necessarily wait for it. You could do something where basically underneath the hood, when I call visitproc, all that does is essentially schedule another FACO probe to file. That's not, it's not a real probe. There's no function called visitproc, but basically, and then you have some mechanisms in place to control how many of these you can dispatch at once, or how many times you're able to dispatch the same thing from the same probe, so that on one hand, we're not literally looping infinitely in the diff execution engine, right? This probe finishes and then we go and execute this FACO thing. On the other hand, you don't want one of these things to go out of control and basically be firing probes nonstop. But you could invent, pragma D option, max subroutine equals, 50 or whatever.
So that would that just be a hard limit on any number of calls where you can imagine this calls X, calls Y, calls X again, back and forth.
Right. This way you don't have,
that would just be one global, one limit to rule them all.
For each, in this fantasy land, which I'm sure some combination of Brian and Adam will tell me is crazy, it would limit for a particular probe firing how many times you can.
It seems like there's kind of two resources that you want to limit. One is like how long does the probe run for? Like what's the maximum runtime of the probe? And the other is like if a function is allowed to call another function, then you implicitly have like a stack.
Well,
so
only if you need return values.
If you want to call a function more than once.
Well, that's in this model. Like we just dispatch these things later,
but
right?
You have the dispatch
do that.
queue, which so you'd have the depth of the dispatch queue.
Yeah, that's true. But like the chances of you calling, like if we were doing like an AVL tree or something, right? You could imagine like,
I think it really depends on kind of where the pain points are. So there's just a lot that has to be would have to be revisited. If the ECP size is dynamic, for example, we rely on each ECP, which is the enabling control block, is able to, it traces a static amount of data.
Right.
And that is that's a simplifying assumption that is used up and down the stack. So like in your example where you're tracing an arbitrary amount of data, now if we can do that with different EPIDs.
Yeah, if that thing has its own EPID, so it's like
right, exactly. This is why it kind of depends on where, it's very important to kind of know where exactly the pain point is, because we can't solve the problem, right? So we can't do this without making some compromises somewhere. So it would be, and that's probably why I asked for the NV list thing too, because it's like if the NV list is like, it is a factor of 10 more burning than other issues, it may be worth doing what we've done with other parts of the system where we actually elevate that into a subroutine.
Yeah. I definitely think like walking lists and trees to some limited depth. Like oftentimes you don't need to walk a list that's 100,000 items long. Hopefully it's not in a list if it is.
Are you walking it to trace it all versus walking it to find something?
Find something.
Yeah, hash table lookups, right?
The hash table lookups. Because that case is a lot easier to deal with than the where do you want to trace the whole structure. Or just like there are. Right.
Like, is anyone, Brendan's written more D than probably anyone in the world, but have you ever walked a list and dumped everything?
I've just used unrolled loops.
Right, but do you actually trace something in each, or do you always find what you want and then print one thing?
I do it in the same approach you did for unrolled loop, where I'm walking a list.
He's asking the answer to my question of like how often do you actually want to dump the entire data structure, the entire list, however long it is, versus walking out lists to find something?
It's usually I'm dumping each element.
Yep. Okay.
I was just going to say sort of the same thing. The uStack helper context might be considered sufficiently arcane that it's not mainstream enough to worry about. But in that case, in the case of V8, you have const strings which are essentially stored in a tree, and you want to print out the piece of the string at each node in the tree, so you end up actually having the entire thing. So you're
Right.
walking the tree and printing out something at every point.
Well, another question is like, do you want to phrase this more as a walker and like a for each thing as opposed to?
I can see use cases for both. I know debugging, like if I'm looking for processes, I'm looking for set processes, for example, right? Or if I'm looking in an NV list, a lot of times I'm looking for just one element on the list.
Yeah.
Yeah.
I mean, so another question is like, the thing that I threw up there was like an arbitrary way to invoke subroutines, not for walking or iteration. Is that useful? Because you can define these macros of incredible complexity to basically act as subroutines and cut and paste that into every probe. Is it just a generic concept?
Yeah, well, especially for the trace stuff, I spend a lot of time doing copy against on specific bits, and if I could reuse that just for code reusability.
Yeah.
Does it get easier if we simplify the problem? Like with NV lists, right? Or you could have NV lists that are nested, which is necessarily almost recursive. But if we limited it to just doing kind of an iterative walk, right? So does that make implementation any simpler?
I mean, the thing I threw up there was knowing limited ECB size, knowing no backward branches, knowing like if we model this basically as a separate EPID, it's mostly just syntactic sugar. It literally is syntactic sugar because you sort of have these synthetic probes, which is a little weird. It's not like, but you have these arbitrary providers. So.
But by the way, this is how we already do. I mean, again, it is weird, and maybe it's too weird, but that is the way we unroll iteration for the USAC helper.
Right.
That's what the USAC helper does.
Yeah. So that's what I was going for, was just like knowing what I think a different question is like, now let's drill in the use cases, and rather than just doing some syntactic sugar, can we build an NV list helper? Can we build a walker for lists that has well-defined, here's a walker, here's a maximum count for the number of times you want to execute this, and like here's a bit of diff to go execute, each time. I don't know if I don't even know what that would look like.
So the function example looks like a useful, so visitproc looks like a useful thing to do in terms of doing subroutines. I still think for iteration, I would like to see the word while or for each, just for the intuitive factor. Like
So-
I would use that, but in terms of solving the iteration problem, I would have another syntactic sugar.
Right. So if we did this differently, you'd be like but it's not a true for loop, right?
It's not true for
For each, right? Like, for each member in this NV list.
But what about this example?
Trace.
I mean,
Yeah, I mean, let me get this back to not this left-right thing, because this is pretty simple.
Just while pointer, not null, iterate, and a mechanism to set a maximum for iterations.
So I think you're bumping into the way that dtrace puts a lot of the implementation very forward. So for example, the D language could have defined, if else, but instead you have to do things through predicates. And part of that is because, we could have hidden ECBs and stuff behind, have through another layer of translation, a D++ if you prefer. But part of the reason we chose to put that forward is because is the same reason why people write in C versus C++. It's very clear to see how those things translate, and a lot of times in D it matters. It matters that everything is part of one ECB or not.
Right.
Or maybe not a lot of times, but enough that it's significant. So if we did something like, if trace a string, else trace an int, that violates some of the supplying assumptions behind that Brian alluded to earlier, and we have a similar problem here. So here we get to a kind of a crossroads of, do we want to maintain this type binding, or do we want to hide some of it behind some syntactic sugar?
Well, I also think that you can go sort of the route of trace mem, which was like, we can't do variable size tracing, so like we're just not going to solve this problem. Where it's like, well, if there's some maximum value, but you dynamically control it. So for example, if else, you could have the max size be the complete execution of all those branches, right? It's like, we know we can compute the maximum size that we will ever trace. And same with this crazy example, right? You can take string of args1, multiply it by 50, and know that we're just going to have a giant, buffer in case we have to walk this thing the full 50.
And we have to include in that, in what we trace, we have to include either which branch of the if-else we took, so we know how to interpret it.
As I say, the one that the ternary operator is blessedly does not allow you to get two.
Well, I'll show you I was hacking up. Okay, so here's ternary 1, right, which is like, great, we can trace, even, odd, do something different based on the PID. It's like, wow, that works. And then let's try, what did I do here? Okay, let me trace either the thread ID or the command name. And that one's not going to work so well.
Yeah, that shouldn't work.
And then there's sort of Adam's case, which is like, oh, I'll rewrite this differently to trace something based on the result, and that definitely does not work.
So again, I think it kind of boils down to what the actual use cases are, and
right.
When you're using if and else. I mean, you got to assume that ternary 2.d and ternary 3.d are not the common case. Where it's like,
yeah, I think probably the common case is like you build up a complicated thing that you store in this, right? Where it's like, and then I want to do something differently based on it. And for one level of if-else, it means you have 3 of the same probe, right? It's like, I have my thing that sets up the data, and I have, okay, the result of that, I'll do this. The result of that, I'll do something else. I assume, Brendan, you've written that many times. And then if you do, once you get beyond that, then it's like, you have to be able to visualize the flow of if-else in your series of probes, right? Because if you had something that was...
There's no reason that can't be done for you.
Right.
But that doesn't mean it has to happen as part of the dtrace command or libdtrace. We can have another. You could have another program, a Perl script, which takes your slightly more advanced languages and translates it into diff. Right.
You bet.
Would that be called dfront?
Yeah. Yeah. I mean, you could take Lua, right, or another language that allows you to. It's pretty easily transportable into other environments, and yeah, you could use that to do that kind of thing, and then it would, or you could even do with dfront if you wanted to use libdtrace.
Right, because if you unroll this, what you end up with is like, this A equals something, and then probe A.
I think, Dave, do you want to claim the world record for depth on this?
The node use-stack helper does a lot of this. Any use-stack helper would.
I mean, the JVM helper similarly does crazy stuff.
You should see the JVM helper. I have to say, after seeing both JVM helper side by side with Dave's, because they actually modified the JVM to make that easier.
Oh, really?
And we didn't get that in the V8. So
I think the
it's brutal.
if you look at like the iteration stuff, right? The advantage of something like this is you don't have these weird like diff max limits that I hit run into and number, so like if you had support in D for this is just one probe, right? But you can obviously decompose it, unroll this. So maybe the first step is like go rewrite, find the things you want to build, rewrite this FACO language, see what you can unroll into usable D. What is pure syntactic sugar versus things that are, would require compiler or kernel support for.
So one example that might be useful, cat user bin iosnoop and look at the bottom of that file.
I don't know if we have that on our systems.
Oh, sorry.
Oh, on the Mac, okay.
And just scroll up a bit. Okay, so see how I've got upstart, do action or run. So I'm actually doing a lot of actions in a ternary operator just to do the optional things. That works.
If you think of something dirty, Brendan's already been there, done that.
It's on Mac OS X, it's been shipped. It works.
Does this work on Solaris?
Yeah, it came from Solaris.
Wait, what's the exact example you gave?
Well, printf doesn't. How does that work?
How does that work?
That is working somewhat by accident.
Oh, wait a minute. I think it's because they're inline ints. So opt starts an inline int.
Oh, so it gets compiled out.
Right.
Oh.
Yeah, so I think another good example is go through the dtrace toolkit, which probably has some of the craziest D around.
Workarounds, crazy stuff.
Take the helpers, the dtrace toolkit, and like some of these.
Well, I guess my question would be, is there a common first step to all this? I mean, I think one of the challenges here, part of the reason this hasn't happened to date, is because it seems to me that there are kind of a bunch of different directions: iteration, conditional execution. They're kind of a bunch of different directions, and I'm not sure. I mean, it'd be good to know if there's something that are, you know, what are the common paths to all of these things. I mean, I think, and on any of these, if one were hot to trot, it's just like take a swing at it, and let's see what we come up with.
Well, couldn't you do all of these things just as a layer on top of D? Like, couldn't you at least spec them out? Be like, iteration is super useful. Let's make a new language that looks like D but has iteration, and then compile it into some unrolled D.
This is how C++ started. Just warning you.
Thank you. That could be a warning from the future. Dan was sent back from the future. After you've ruined D with D++. I mean, I think that, I guess my question, this is part of why my question is like, what is the burning on here? Like, I know the lack of conditional execution on the useStack helper was definitely burning for Dave. I can just feel the pain on ND lists. I mean, just, that's got to be painful. It's mostly very frustrating when you're doing a function that only takes an ND list in the kernel and trying to make
hash table walking is
the hash table walking, and
definitely painful.
And maybe we just take like one of these that's particularly painful, and
It gets back to barrier of entry though, right? I mean, this is the problem when you sit down to write a dtrace script and you're like, hey, I have a hash table of file descriptors. I only want to fire verbal file descriptors I care about. Oh, it's like now I have to go look through 100 dtrace scripts to try and figure out.
Or even if we write the meta language, if it's not baked into dtrace the command, it's like, oh, make sure you run dtrace ++ pipe to dtrace and stuff like that. So, but we.
You need to screw that with syntax sugar. Right?
Yeah, but even.
But I'm just saying it should be baked. Like you shouldn't be new options to dtrace. It shouldn't be like some pre-process. Like make sure you use -cap_c. Don't use -cap_c. Like
if the D+ is backwards compatible, then you can just be like, oh, the new default is that you were compiling.
I think what Adam was saying was that, and correct me if I'm wrong, I think what you're saying is that like you could do it, you could front D as a way of experimenting with these ideas. I think part of the challenge here is these ideas are not cheap to experiment with. These ideas are going to be.
I say differently. They're cheap to experiment with. They're very expensive.
Sorry, that's what I mean. They are very expensive to actually implement properly. So I think they should be implemented properly once we've got a direction that makes sense. But we need to experiment with that direction.
Right. Knowing which of, just even the iteration example, which of those is going to be most useful. Like, don't know. But the implementation is significantly different enough that it's worth.
Well, it may be that, like, I could totally see, for example, that you see, actually, if we could just do conditional execution that does not allow you to change return type, and we really constrain conditional execution. In other words, not create EPIDs and ECBs underneath you. Yeah. Same ECB, one ECB. It's basically a better-looking ternary operator that allows you to nest. Right. That would be, that would allow us to do, and maybe we need to take that a step further to allow the useStack helper to alleviate some of Dave's pain. Maybe we need subroutines, right? We can go, I would just love to get the kind of common element that we can then just go.
I mean, maybe we can just start with some wiki, which is like, what is the most complicated, annoying D you've ever written?
Oh, that's a good idea.
And then how would you rewrite
Take the helpers, take some of Theo's stuff, take the toolkit, take Pornstar's D that you wrote up, and just like start to, like, what is the most annoying D you've ever written? I'm sure Jared has.
So surely one of the best things for us to do is to identify the patterns of usage.
Right.
If we pattern the usage, we can actually put it on a wiki, then whether this goes any further or not, it actually becomes a pattern of usage which can be consulted for those people who are interested in joining the language as well. Yeah. Because as we said, one of the barriers of entry is the fact that we don't have these documented, and people, as Brian says, have to look over 100 or more scripts to find it. Yeah. The patterns help us identify what's useful. Yeah. They give us best practice, and they also actually help anybody who's trying to pick up dtrace.
So, Matt, I think we should go to lunch.
Yeah.
Yes. So I think we,
this is actually like an actionable thing that we can go do, and I grab some space on the dtrace wiki somewhere, and just like.
I love world's worst D, by the way. The world's ugliest D, because I think that points us to where the pain points are too. So, great. Schrock, thank you so much for that.